We have a wonderful speaker tonight. Dr. James Rice is an astrogeologist with over 25 years of research experience specializing on the surface geology and history of water on Mars. His career includes working for NASA, Astrogeology Headquarters of the United States Geological Survey, the Mars Spaceflight Facility located at Arizona State University, where they make those cool mirrors, right?
That's University of Arizona. 100
Uh-huh.
miles down the road.
Okay, sorry about that. And the Lunar and Planetary located at the University of Arizona. Dr. Rice is Co-Investigator on the Mars Exploration Rover, Spirit and Opportunity. So with that, thank you very much. What we're going to do this evening is hold the questions until the very end, and then we'll have a Q&A session. And we have our slide presenter, Keith, is actually going to be forwarding the slide. So we're on slide number 1. Dr. Rice, it's all yours. Thank you.
All right, thank you. Well, how are y'all doing tonight? And thank you for coming out. It's a privilege and a pleasure for me to speak to you about what we're doing on Mars. It's a lot of fun because this is something I've dreamed about as a little kid. And actually, I'm at my mother's house visiting her in Alabama. That's where I'm from originally. And so when I go back to my room and when I stay here, this is where all these dreams I got came from when I was living here as a little boy. But so the first slide, it's kind of a neat picture. I like it because it's sort of a, I guess nowadays the jargon is a selfie, the best we can do with our rover. It's a picture of our shadow, but you can see that if you look at it very closely, you can see a couple masts sticking up where our cameras are mounted in that shadow. And we're looking towards the east. So this picture was taken in late afternoon on Mars. The sun sets in the west, just like it does here on Earth. And you can also see in that picture the wings, our solar panels on the deck. We're a solar-powered vehicle. These rovers, Spirit and Opportunity, the size of a golf cart, weigh about 470 pounds on the Earth, about 1/3 that on Mars, roughly. And if you look down at the bottom of that picture, you can see our wheels. We have 6 wheels. It's the lower right. You can definitely see one of them partially illuminated. And our wheels are kind of small. They're only like 25 centimeters in diameter. But we have 6 wheels, like I mentioned. But let's go to slide number 2. And I'll do that one because the question I always get is, people always want to know how big these rovers are. And this is a nice slide here because it gives you a graphic detail. The small rover down there in the forefront is Sojourner. That landed on Mars. It was the first rover to ever work on Mars. It was part of the Mars Pathfinder project. It landed on the 4th of July of 1997, which is kind of a neat present for our country. It's about the size of a microwave, weighed about 20 pounds. Didn't drive very far, but that was the first successful rover, and it was solar powered. It strayed maybe, the furthest distance from the lander it got was maybe like around 50, 60 feet, not very far. But it's a kind of an engineering proof of concept. And if you work your way up from that, you see Spirit and Opportunity, which have the solar panels, the wings I told you up there on our deck. That's the rover on the far left side, size of a golf cart roughly. You can see the 6 wheels I talked about. And the mast where our cameras are mounted, the pan cam camera where the color pictures come down. We also have our navigation cameras up there on the mast. And it's interesting because that mast is about the height of a normal human being's eyeballs above the surface of the planet. So it gives us a good sense of perspective. We can take stereo because we have left and right lenses, which is very helpful for determining distances for our navigation for the rover driving and for doing science. The other rover there, that's the big one most people are probably familiar about because it landed on Mars, was almost 3 years ago. That's Curiosity. It landed on August 5th, 2012. It's not solar powered, it's nuclear powered. But all 3 of these rovers here travel the same speed on Mars, okay? You would think that the newest one, Curiosity, with nuclear power would go faster. Nope. They all travel the same speed. It's very slow. Because another question people always ask me a lot is how fast do they go? And you'll be really surprised how fast they go. They go about the speed of a Galapagos tortoise, very slow. But you have to remember, it's not a race up there, and there are no roads, no trails, no nothing. Okay, we have to pick our way literally every centimeter. We have to pick our way through rocks, craters, sand dunes, hills in some places. So it's kind of tough going, but the thing we're up there to do is to explore. So we're not trying to put mileage on these vehicles to see how fast we can drive them. We're trying to explore the planet. And we're going somewhere by nature that no one's ever been before. So we want to kind of take our time to some respect. But on the other hand, we do have strategic planning. We have distances we want to get to by a certain number of months down the road. So we kind of have to stay dedicated and focus what we're doing. But we let the science drive us. And that basically depends on Mars, because we don't know what Mars is going to throw at us, good or bad. And if we come across something really exciting, we're not going to blow by it just to be by somewhere by a certain date. Because the media always asks us when we're going to get to the so-and-so location. And it's hard to answer because we don't know. And depends on what we find in the meantime. If we find, the proverbial dinosaur bone, we're not going to blow by that. We're going to spend some time there. We're not going to find anything of dinosaur bone. It's a joke we have on the team. But if we find something really juicy and interesting scientifically, our schedule goes out the window, because that's what we're there to do, is explore. But and you can see that Curiosity is the size of a Mini Cooper car. It weighs a ton. A lot more capable rover in some respects in terms of the science instrumentation on there. It has different instruments than we have on Spirit and Opportunity. But like, as I was saying, it travels no faster. Actually, Curiosity is having some issues with their wheels because they made them very thin. The engineers did I don't know, they do a great job, but they kind of missed the boat on this one, because those wheels, if you're keeping up with Curiosity's mission, are getting punctured by rocks. And they're almost like Coke cans, very thin. And they're concerned on the project that this could cause some big issues down the road. And so now they're trying to avoid real rocky areas because of the damage the wheels are suffering. There's not a showstopper now. It's something they're keeping track of to monitor, because you don't want it to get worse. And the main concern is if some of that metal breaks off loose, it can get into the electronics in there. It can short circuit the rover, and that could be some bad things happening. You would maybe not be driving anymore or doing anything. So the concern is not really the little holes being punctured, it's the holes getting larger and metal shards flaking off or getting trapped in the motor housing or something. That's really the main concern with that. So anyway, let's go to the next slide. I don't know how much you know about Mars. May know a good bit. Some of you may know more than others, but I'll just start with some basics, facts about the planet. This is kind of a nice slide because it really summarizes a lot out about the planet. So you can see it's about half the size of the Earth. The day is very interesting on Mars, almost like an Earth day, a little bit longer. But look at the year. Mars is further from the sun, so it's naturally going to take longer to go around the sun to complete its orbit. So that's roughly about 2 Earth years. The gravity, like I mentioned, is 38%. And so, if people ever want to know how much you're going to weigh on Mars, just take your body weight, multiply it times 0.38, and there you go. I see a lot of people like to go to Mars because you're going to be about half your age and about a third your weight. I think most people kind of like those kind of things. But if you go, you better bring a spacesuit, because as you can see, the atmosphere is 95% CO2. There's no oxygen to breathe. The atmospheric pressure is 1% what we experience at sea level on Earth, so it's about equivalent to being 20 miles above the surface of the Earth, the Martian atmosphere. It's not much of an atmosphere at all. It's just enough to be a problem with landing. The temperature is a cold place. A lot of times people ask me how it's hot. I guess because it's called the red planet, they think it's hot. I don't know where that comes from. But Mars is basically it's a frozen desert world. It's a very cold place. The average temperature in Fahrenheit, if you wanted to do it globally, it's about 70 below zero. A global average there. Earth's temperature globally average is about 65, 70 degrees Fahrenheit above zero. So it's a cold place. The next slide. I think this is a nice graphic too, because if you took all 7 continents and squished them into a ball, that's how big Mars would be, all right? And if you take Africa and we're able to squish that into a ball, that's the size of the moon. So that's a nice little device to keep track of relative sizes of these 3 bodies in space in our solar system. And you can see even the moon, which is smaller, it's a large amount of area to explore and to discover up there what's going on, because Apollo missions landed on 6 points. The Russians landed handful of robotic missions, but there's still a lot of the moon we don't know anything about. the polar areas we've never been to, which may be some of the very interesting places on the moon because of ice being trapped at the poles. And so, but the moon really, in the last I don't know, I'd say the last decade or so, the moon has changed. We thought we kind of had it figured out after the Apollo program, but the moon is a lot more complex and interesting than we thought of. And even in planetary science community, I mostly work on Mars, but the moon is very interesting to me. It's very important, I think, for our future explorations. But a lot of people think it's just a ball of volcanic rock, and that's about it. All there is to it. But like I said, the last few missions, robotic missions, Lunar Reconnaissance Orbiter, which is a NASA mission, currently in orbit around the moon. The Indians have sent a mission, and the Japanese. We've learned a lot about the moon in the last decade or so. That's kind of changed our views of what the moon is all about. And of course, Mars is the plum of the solar system. I don't care what anybody says about Europa or Enceladus. Those are neat places, but everybody wants to see, and the question I always get is, when are we going to send astronauts to Mars? Mars is the plum. I mean, it's in our human psyche from science fiction stories. It's just where we want to go. It's the most Earth-like planet. In terms of other planets, that's the first place we're going to go to set up any kind of future colonies or settlements to live off the Earth, other than the moon, which is a lot closer. But Mars, everybody likes Mars. Everybody's excited about Mars. Now, granted, there are other cool places in the solar system, don't get me wrong. I mentioned Europa and Enceladus. But Mars is a special place in our imagination. And I think, and you can look at the history of NASA's exploration, it's been the focus. And some of my colleagues who work on other objects in the solar system, like asteroids, comets, or the outer satellites around the gas giants, they're a little jealous because Mars gets a lot of special attention. People love Mars. I don't know, it's just the way it is. Well, in Mars, there's some interesting landforms there. For a planet only half the size of the Earth, this is a giant volcano. You're looking at it from orbit, looking literally down the throat of this volcano. The name of it is Olympus Mons. And I live in Arizona now, so as Arizona, outline of the state of Arizona, it would cover the state of Arizona up. That's about 300 miles across, that volcano. And it's enormous. And it's the largest volcano in the solar system. This picture was taken, like I said, from orbit about 200 miles above the surface, looking straight down into the caldera, the crater where the lava came out of the volcano. Okay, this is a neat view to give you in terms of the diameter of this big shield volcano, but you probably wonder how tall it is. Next question. So the next slide, this compares it to Mount Everest, which is the highest mountain on Earth, and Olympus Mons is about 3 times taller than that, okay? Olympus Mons would literally almost be up into outer space on planet Mars because the atmosphere is so thin at the summit. A giant feature, and once again, this is a giant volcano on a planet half the size of the Earth. There's some other amazing landforms on Mars, and if you go to the next slide, there is this large canyon system that grabs your eye in this view. This was taken from the Viking spacecraft back in the mid-1976 as it was getting ready to prepare to go into orbit around Mars and dispatch its landers, which were the first successful robotic landings on Mars on July 20th, 1976, and then a couple months later, on September 3rd, 1976, Viking 2 landed. But you see the big canyon system across the equator? That is called Valles Marineris. That is really, truly the Grand Canyon of the solar system. Also, in this nice orbital view, if you look over to the left-hand side, you see some kind of dark bumps over there. Those are large volcanoes. The big Olympus Mons you can't see in this view is kind of around the terminator of this view here, off to the left. But those 3 big volcanoes, Ascraeus, Pavonis, and Arcea Mons, are part of the Tharsis volcanic complex. And they're pretty large in themselves. Not as large as the Olympus Mons, but large volcanic features. And then you can see, if you look real closely in this view, you can see a couple large impact crater basins. There are a lot of craters on Mars, but this view only shows the largest ones. The other thing that gets of interest, if you look kind of in the center, going up towards the top of that, it's like a light kind of tan colored ribbon stressing up through there. That is the floor of an old outflow channel called Kasai Valles, where enormous volumes of water gushed through there in the past. And these outflow channels, for several of them on Mars, they dwarf any type of flood features on the Earth. So Mars, once again, it's got the largest canyon system, largest volcano, and the largest flood channels in the solar system. And if you go to the next slide, this gives you an idea how big Valles Marineris is compared to the continental United States. It would stretch literally from the east to the west coast. And this is a shaded relief map of Mars. In the background, you can see those 3 big volcanoes we saw earlier in that previous orbital view. And you can see a lot more craters popping up in the shaded relief topographic map. And you can see that outflow channel coming up, going above north continental United States, flowing off to the east over there. So a giant canyon, a giant volcano, enormous flood features. And to give you an idea, if any of you ever been to the Grand Canyon in Arizona, that's a pretty amazing landform to feature to go see in person. When you're there, it just kind of, it blows your mind away. The first time I saw it in my life, I got numb from my head to my toe. Okay, I'm a geologist. Maybe you didn't feel the same sensation, but if you go to the Grand Canyon and see it or hike down into it, it's a pretty amazing feature. Well, compared to the canyon on Mars, it's a twiddly little thing, very small. The Grand Canyon is a mile deep. The canyon on Mars is 4 times deeper than that. It's 4 miles deep. And then the width, it dwarfs it. The Grand Canyon, its widest point, is around 18 miles wide, but Valles Marineris is up to 150 miles wide. So you can see truly the Grand Canyon of the solar system is on the planet Mars. And if you do go to the Grand Canyon, it's like a large, immense feature. It kind of just dwarfs you as a human being. You know, and imagine if you're on Mars looking at the canyon, what you'd feel there. You probably wouldn't be able to see to the other side because of the curvature of the planet. It's a smaller planet. I don't know, I haven't figured it out, but you might have a tough time seeing across the 150 miles across the other side. Like with the Grand Canyon, Arizona, it's very easy to see the north rim from the south, or vice versa. This one, you'd probably lose it as with the curvature of the planet falling away from you. The dust in the atmosphere is going to cut down the clarity. And to be honest with you, the colors of the rocks probably won't be as exciting as what we see at the Grand Canyon in Arizona, because the colors of rocks on Mars are going to be more muted, and they're going to have a coating of dust that's been accumulating for billions of years, which is going to kind of dampen out any kind of lighter colors that we might see there. The next slide is kind of like our philosophy in terms of our scientific exploration philosophy of Mars. Water is the common denominator, the common thread. So we're in the stage of what we call follow the water on Mars. And water, is pretty obvious, the importance of water. You can see, there's no life as we know it can exist without liquid water. Water also drives your climate and weather systems, both on the Earth and Mars in the past. I'm a geologist, so the water story of the geology is very important, because if you know what you're looking for as a geologist, the water history is imprinted across the surface of Mars in terms of its landforms and the minerals that make up its rocks and soils on the surface. So the geology is kind of there in front of you. When you study Mars as a geologist, it's like when you look at a picture of Mars, it's like a page out of a history book. If you know what you're doing, you can read. There's a lot of clues there just staring you in the face. And so the water ties in very importantly there, because all the water on Mars now is no longer liquid water there. It's not stable because the atmospheric pressure is too low and the temperatures are cold. So any water on Mars today is solid form, in the form of ice. And if you look at that picture, you can see the north polar cap of Mars over there on the left. And there's also a south polar cap, but the north polar cap is larger. That's mostly water ice. The north, the south is some CO2 ice with a veneer of water ice on the south pole. And the final thing is the human exploration. And hopefully that's going to happen not too far down the road. I wish I could tell you when we're going to send astronauts to Mars. Unfortunately, we have no real timeline, despite what you hear in the media and what people in NASA are saying. We're working on sending astronauts to Mars. Hey, sorry to inform you, but that's so far down the road. And that time schedule they're working at right now, if you want to believe it, it's in the 2030s. Do you really think that's really going to hold? I mean, talking about 20 years from now with all the political changes that will happen in 2 decades. It's unfortunate we don't have a deadline like we had with the Apollo program within a decade. Until you have a firm deadline, immense projects, complicated projects like this, it's basically what's happening right now is that's being kicked down the road, okay? The funding isn't there to do this. Despite what you hear in the news, I hate to burst your bubble, but we are nowhere closer to sending people to Mars today than we were 10, 15 years ago, okay? It could all change if we get the right leadership and the proper funding and the willpower to do it. But as we speak this Saturday night, Mars is still a dream of sending people there. And it will happen, I have no doubt. I just don't know when. And unfortunately, I don't know what language they're going to speak or what flag they're going to fly. It's not a guarantee the United States will be leading that, the way things are going. But anyway, the reason the water is important for human exploration is there is water on Mars. So that means you don't have to carry all that water with you from the Earth. And if you ever go hiking, a gallon of water is pretty heavy. It weighs about 8 pounds, all right? So water is very heavy, and when you try to lift heavy mass off the Earth, that translates into expense, money. So if you have water sitting on the planet Mars, that's going to cut down your cost of getting there. And that water is surely going to have to be filtered out. You'd melt the ice, you're going to have to filter it, but you got drinking water. If you go in the mid to high latitudes on Mars, there's ground ice right below the surface, a couple inches, and as you get close to the poles, the ice is sitting on the surface. But you melt that ice, you have drinking water, which you have to have to live. But water also is very interesting because when you break it apart, everybody knows it's H2O, right? Well, hydrogen and oxygen is also rocket fuel. When the space shuttle used to fly before it was retired, that orange tank that the orbiter was mounted on, the external tank, was full of liquid oxygen and liquid hydrogen, rocket fuel. So water is a very valuable resource. Also, you can break that water down to its component, hydrogen and oxygen. You get oxygen to breathe, which is very important. So water is the most valuable resource in exploring space. More valuable than any gold or diamonds or silver, because you can do a lot of things with it. A lot of things that keep you alive, which is very important. So, like I said, water is the common thread. And if you go to the next slide, it's all about water on Mars. Now, I don't think you can buy Mars candy bars in the United States anymore. As a kid, I remember buying them, but they're hard to find. I don't know why they don't sell them here. Mostly you can find them in Europe. And if you look at that label very closely, it's some of it's in French. So I don't know. Anyway, so that's an attempt to be funny, water on Mars. Okay, next slide.
That's good. That's good.
Is the next slide is Mars is a dangerous place to go. It's the graveyard of the solar system. And as you can see, I don't need to read all that to you, but basically 2/3 of every mission that planet Earth launches to Mars is a failure. Most of those failures are the Russian failures. Okay, and but the United States has had some failures. And I worked on one because you see, for landing on Mars, we're the only country that's landed on Mars. We're 7 for 8. And the one failure we had was Mars Polar Lander back in December 1999. I was on the imaging team for that one. And another thing you don't hear when these things do fail, you hear about the X amount of dollars it costs, okay? But the media never talks about what happens to the people working on those projects. The engineers, for the most part, will move on to the next project, but the scientists are left twisting the wind. You lose your job, okay? So when Mars Polar Lander crashed back in 1999, I lost my job along with a lot of other people. Not because we did anything wrong, just flying to Mars is a dangerous prospect. It's a dangerous place to go. And this kind of career field isn't for the faint-hearted because you can see this is not a very good success rate, 2/3 failure rate. But it's important to keep doing it, and there will be other failures. That's part of space exploration. It's a dangerous endeavor, and when you involve people, everybody's familiar with the Challenger and Columbia accidents, but also goes back to the first astronauts we lost back in Apollo 1 fire in 1967, preparing the first Apollo mission. It's just space flight's dangerous, and it's going to be that way for a while, unfortunately. And because when you ride a rocket, you're riding a controlled explosion, all right? And so it's just, like I said, it's not for the faint-hearted. Next slide. This was our kind of marching orders for MER's, the Mars Exploration Rover, our science goal. And if you ever see a goal or objective that takes a paragraph to write, that's not a very focused goal. You should be able to do it in a sentence or two. And maybe these sentences get kind of long, but if you have a goal that takes a long way to explain, I mean, it's not a very focused goal, not very good. But our goal was to determine the aqueous, that means the water history, the climatic history, and the geologic history of 2 separate sites on the planet Mars, and to see if those conditions may have been favorable for the preservation of any life or prebiotic processes that got going on there. So we're looking for habitats or environments where life could have thrived, based on our experience on Earth, of course. So that was our marching orders, and another thing you have to remember, when we launched MER, it was in the summer of 2003. They were launched several weeks apart. And at the time, the last time we tried to go to Mars, we had 2 failures. We had that polar lander that I talked about, I worked on, we failed. A couple months before that, we had an orbiter, the Mars Climate Orbiter, burn up the atmosphere. So NASA has a black eye from that, but also we had a big black eye from losing the Columbia crew in February 2003. So we had a lot of pressure on us as a project, and we heard about it every team meeting we had before we even launched, because the NASA administrator at the time, Sean O'Keefe, was a good friend and golf buddies with Dick Cheney, who was the vice president at that time. And it all rolls downhill. We heard every meeting that these missions better work because NASA's reputation's riding on it. We're spending almost $1 billion. Y'all guys better get it right. Well, of course we're going to try and get it right, and we did our best. But you never know what Mars has in store, because when you launch and then 7.5 months later you land on a planet, there are no weather reports that go that far. We don't even have weather reports, reliable ones, on Earth. Okay, so you don't know what Mars is going to have in store for you. And you also got to remember our landing ellipse was about 100 kilometers, about 15. We didn't know exactly where we were going to land in there. So there's a lot of, back in those days, there's a lot of pressure on us, and we were glad to take that pressure on, and we thought we'd do a good job. But yeah, we heard about it every meeting, and it really, I think, made us redouble our efforts. And we got a real great team of engineers and scientists, and I think as I'll speak, you'll see that proof is in the pudding. We're still driving on Mars. We spent several years looking for landing sites on the planet. There were certain engineering criteria we had to meet, but one of them, they had to be located pretty far apart. This was the first and only time twin rovers had ever landed on Mars, all right? And it took different operations because we landed on other sides of the planet for a logistical reason. When one rover, they're solar powered, when one rover's up and working, the other one's in darkness. So that means that team can sleep and rest, okay? And then Mars rotates around, and the other one wakes up. And when the sun comes up on Mars, those rovers wake up and ready to go. And if you're not ready, you're wasting valuable time. You're burning money. So it was interesting to live on Mars time. And you may think, well, that's about 37 minutes longer every day. You can sleep later every day. No, it doesn't work that way. Just call it 40 minutes. It accumulates every day. So if you go to work Monday morning at 8 o'clock, about 11 days later, you're pulling the graveyard shift, okay? And it's always changing. You don't have a set schedule. If you see pictures of us back in those days, a lot of us had two wristwatches on. One was for Pasadena, California time, where we were living, the JPL. One was Mars time, and it depended on which rover you worked on, okay? Because the planets are on opposite sides of the planet. And Spirit was on the fourth floor of building 264 out there at Jet Propulsion Laboratory, and Opportunities to the fifth floor. That one flight of stairs was massive jet lag because you go through several time zones going one flight of stairs, okay? One planet, one side of the planet to the other. It's a weird time living like that, and eating breakfast sometimes at like midnight or 1 in the afternoon. It's a weird schedule. And we lived on Mars time for about 5 months, and we finally transitioned off. The rovers were only supposed to last 3 months, 90 days, 90 sols. A sol is what we call a day on Mars. And rovers didn't want to die. They wanted to keep going. But we landed Spirit in Gusev Crater over there on the right, and Opportunity landed in Terra Meridiani. And you can see these sites are fairly close to the equator because we were solar powered. We want to get enough energy from the sun. And but there was a reason we landed them on opposite sides of the planet. And here's what the rovers look like. I won't go through every one of these instruments on here, but we have a lot of cameras there. And we have this arm that sticks out. It's about the size of a human arm. It has a shoulder, an elbow, and wrist joints. And instead of fingers, we have instruments out there, spectrometers, to measure the composition of the soil and rocks we drive up to and measure. And we have pictures, cameras. We get the big pictures, the color pictures, the pretty pictures I'll be showing you. We also have cameras down there in the belly of the rover, fore and aft. These are hazard avoidance cameras. And this rover can be driven forwards or backwards. Okay, it didn't matter. It didn't really care. The camera can swivel around. So the front usually is where the arm, we call that, but we do a lot of the driving nowadays backwards because our wheels are starting to wear out and the bearings, and so it's easier to drive backwards. So, but the rover really doesn't care. So the next slide is the launch of these vehicles. Spirit went first. It was a daytime launch. And then about not quite 4 weeks later, Opportunity was a night launch. And I got to tell you, Opportunity almost did not make the launch to Mars because you have launch windows when you can launch. And if you don't make that launch window, you're going to sit and wait about 26 months for the planets to realign to go. And we were getting very close because we had a lot of problems with the launch vehicle for Opportunity. Because this, if you look at those pictures, especially if you look at these identical rockets, these are Delta II rockets, you can see that green band of material kind of in the center of the rocket. Well, that green band is a lot of insulation on there because there's a lot of liquid oxygen, liquid fuel on there, and it gets real cold. And this is kind of like a thermal insulator to keep all the ice from forming on there. Well, a lot of that is made of cork. A lot of it's corked and it's glued on there with a special kind of glue. Opportunities, that cork kept kind of peeling away from the bonding, and we had to cancel it several times. We were ready to launch one night, and a boat was in the wrong area. We had to cancel the launch for safety. I hope that guy got a big fine for that, because then some bad weather came in Florida, because in Florida in the summertime, you have a lot of thunderstorms there. Anyway, we made it with Opportunity. We only had like about 2 weeks to spare, and if it hadn't made it in that window, it was going to sit for 26 months, all right? And that would have got expensive, and I don't know if we'd ever launched it or not, but it all worked out. But it had a rough start. The next slide, this was taken the night, a couple hours before Spirit landed. Spirit landed first. And the guy in the center there is Steve Squires, our boss on the science team. And that's our science operations room we're in at the Jet Propulsion Laboratory. And we're sitting in there, and he's basically telling us, I hope you got a lot of sleep, because this is going to be crazy. It's going to get real exciting real fast once we land on Mars. And a couple of us in that room had worked on projects. Like I said, the last time we tried to land on Mars, we crashed. And there are several of us in there that worked on that mission. And, it's not a slam dunk. You're going to land safely. But you have to be optimistic. We have a good team. We thought we had everything ready to go. But in the back of your mind, you always got to think, it could end. And he's basically saying this is going to be a lot of fun. It's going to be a good time. Because as a scientist, this is what you want to do. This is like winning the Super Bowl. If you work on a mission that gets to land on the surface of Mars, and hopefully it works. I remember after this meeting, like I said, this was a couple hours before Spirit landed. It was a Saturday night, early January, and I went outside, and Mars was in the sky, and looked at it, and I'm thinking to myself, in about an hour or so, the way I look at Mars, again, will not feel like this way I feel right now. I'm either going to be pretty happy we got a rover there, or I'm going to be disappointed we just crashed and I'm going to lose my job. So either way, when I see Mars for the next time, it's going to be a different feeling than what I have right now. But anyways, this is this little pep talk he gave us. And sure enough, Spirit came down with these a heat shield, parachute, and airbags, and bounced and rolled. And we had no signal from Spirit for 10 minutes. And if you look at that guy in the red shirt is the NASA administrator, Sean O'Keefe, and standing next to him is Steve Squires. And there's a lot of concerned looks on everybody's faces in there. And because we had no signal, we thought this thing crashed. And I don't know. There were people next to me in the room, and they were really down in it. I had a gut feeling it worked. I don't know why. I just wasn't concerned too much. I was like, this thing's going to work. And after 2 minutes, what happened is it was rolling those airbags, across the surface of Mars. And the antenna was pointing away from the Earth, so we weren't getting a signal. But eventually we got it, and then the next slide, we're all very happy for several reasons. Number one, we're on Mars, that's the main reason. And we're going to be able to do some fun stuff. We were trained years to do, and explore part of the planet's never been explored. So we're all happy. Also in the back of our minds, I'm not going to lie, we're happy we still got a job, So that's one reason. There's several excitement in there. And so Spirit landed okay. 3 weeks later, Opportunity came down, did just fine. And so going to the next slide. This wasn't really a secret, but we kept it to ourselves and the team. I mentioned we had the Columbia accident that happened before we launched. And so once we got safely on the surface of Mars, we flipped our high-gain antenna around, and each one of the rovers had this little plaque on the back. It's the mission patch for Columbia and the name of the 7 astronauts on the Columbia mission. We did it in their honor because they literally gave their lives for exploration of the solar system. We wanted to honor them. And so this is really a neat picture. It's solar panels, those black-looking things, and our airbag is up there in the upper right. And of course, in the background, it's the surface of Mars. And that was a cool thing we did. And an interesting thing that happened with Spirit, which landed first, is we looked off to our east. And if you go to the next slide, there were these hills over there, and they were about 3 kilometers away, about 2.5 miles. Well, the rover is only supposed to go, at best, about 2,000 feet, about half a mile. Well, this is too far away, and we're thinking we're never going to get there. But it was interesting how this kind of worked out. As we looked off to our east, we saw these hills. They came to be known as the Columbia Hills. And it just so happened there were 7 hills there, and each one of them was named after each of the 7 members of the Columbia mission. Very interesting how that worked out. And so you're looking across the floor of Gusev Crater, the Columbia Hills over there, and as geologists, that's where you want to be. Flat areas are kind of boring. You want to go into hills or canyons or craters. That's where interesting geology is. But none of us in our right mind thought we'd ever get there, and so our first job is to explore our immediate surroundings and learn what's going on. And the reason Gusev Crater was chosen for a landing site is because a big channel empties into it from the south called Ma'adim Vallis. In Hebrew, that word means Mars. And all the big outflow channels on Mars are named after different languages or cultures' word for Mars, like Kasai is the Japanese word for Mars. Ares Vallis is, of course, a Greek god of war. But Ma'adim flowed into this big crater called Gusev, and the thinking was it must have been a big lake in there. Okay, got a big hole in the ground, the crater, and channel flows in there. But several of us on the team, after doing detailed analysis of all the orbital images, didn't think that really, this lake story kind of really panned out, like it was being sold at landing site meetings. So we land there, and sure enough, it's not a lake bed we landed on. That's a busted up lava flow we landed on, and all those rocks out there, basaltic pieces of basalt from a lava flow. It's been impact garden from impact craters over billions of years. No signs of any lake there. A lot of disappointment came in on the team because we were supposed to follow the water, and there we are on a busted up lava flow. Nothing to do with water. So we're thinking, let's explore our area around here, and then let's go for the hills. And if we don't make it, we'll die trying, but we got to do something. So we spent a couple months exploring our immediate surroundings, and in March of that year, we took off for the Columbia Hills, and we didn't really think we'd make it. We weren't certified to drive that far, but we made it to the Columbia Hills. We actually, the hill on the left of that picture is Husband Hill, named after the commander of the Columbia mission, STS-107. That's the highest hill in the complex. Spirit actually climbed that hill. Wow. And the next slide gives you an idea how tall the hill is, because they're not really mountains, they're hills. It's about the height of the Statue of Liberty, Husband Hill. But the rover was never designed to climb anything like this. So once again, like I said, the engineers did a great job. So we climbed that hill and looked around at the top, and then we drove down the south flank of it. And the next slide, this was a view from the summit of Husband Hill looking south. And there was a lot of features down there, very interesting features. So I approached Steve Squires. I said, look, I got an idea for the names of these features down there. And he said, well, what is this? So this is kind of like our space Hall of Fame Ring of Honor, like, okay? And so we had this feature called Home Plate, which we saw from orbit. Some weird looking kind of, it's about the size, it's about 100 meters across, about the size of a football field. And but then around there, there's all kind of little mesas and buttes and ridges. And so these are named after famous people involved in space programs of the United States and Soviet Union, and even where these hills come from. McCool Hill was a member of the Columbia crew. Ramon Hill was also the Israeli astronaut on the mission. So we looked down this little valley, we call this the Inner Basin, and we drove down there, and that's where Spirit's resting as we speak today, kind of over there near Tsiolkovsky, between that and Home Plate, where Spirit died. But we explored the Home Plate area. We never made it to Goddard or Von Braun. That's where we were planning to go. But we got stuck in a little small sand pit with Spirit, about 100 meters from Von Braun, which was an interesting butte of layered rock. And then the Goddard feature, it's hard to tell in this view. Goddard is a weird, kind of like a crater. We think that could be possibly a volcanic vent, but we just, like I said, we never made it there. But the next slide, this is probably the biggest discovery Spirit made, and you may look at it and think, pretty boring. I mean, what is that? Dirt and a couple of rocks, and yeah, okay, so some of that dirt looks kind of whitish or tan compared to the red. That's a very important discovery we made, because that is almost 92% pure silica, that white, light-colored, white-looking stuff. And you may be thinking, well, so what? Well, it's interesting how we found it, first of all. The Spirit's right front wheel quit working a couple months before this, and it locked up like a bad shopping cart. And so we drive backwards, we're dragging that wheel. And that wheel, because we're dragging it, uncovered that white soil. If it hadn't been for that, we wouldn't have seen this soil properly, probably driven right across it. So it makes you wonder what else is below the surface we could have missed, and who knows. But we found this. By dragging that wheel, we found this white colored soil, which is silica. Now, silica is interesting because to create silica on Mars, you need a lot of water. And this area, we think what happened here is, you ever been to Yellowstone or seen any active geysers? That's what all those geysers are made of, silica deposits, the center deposits. So in this area, geysers and hot springs were going off on Mars billions of years ago. And that's very interesting also because some of the current thinking is that life got started in these black smoke vents on the seafloor or hot springs on Earth on the surface. Silica is also important because the water is cooking and the heat is cooking these rocks, altering the minerals to turn it to silica. So you need a lot of water there for a sustained period of time, a heat source, which will be volcanic in this area, just like Yellowstone. But also silica is important because if any little creatures are living on Mars, they're entombed in that silica. It's a perfect place to preserve any biologic material. Now, we don't know if that happened there or not, but that is what you look for on Mars to see. If we could get some of that back here on the surface and analyze it, we could see if there's any little, entombed little critter Martians in there. So the silica is a big deal, and so that's a very important discovery we made with Spirit, and it was kind of almost serendipity because we had a bad wheel, which we were all disappointed in. But that bad wheel, even when bad things happen on these missions, good things still happen. So it's I don't know. I've told people several times there's somebody upstairs that likes these rovers on Mars. This is it's the last picture taken from Spirit, looking to Von Braun Butte over there.
Wow.
And it's about, like I said, about 100 meters away. And that's where we're getting ready to head when we got stuck in this soft material. And what happened to Spirit, it got stuck in this area, basically froze to death, because when wintertime would come on Mars, we learned just trial and error to climb up a little slope or a hill facing north to get the maximum solar insolation in the winter. Because Mars has seasons just like the Earth. They're about twice as long as the seasons on Earth. So we weren't able to do that with Spirit, so the solar power decreased, and the vehicle basically froze to death. And when it got so cold, solder joints started popping and all kind of things. Probably computer chips cracked and the heaters quit working. So it basically just froze to death and is sitting in place. It better still be there. It shouldn't have moved anywhere. So if we were going to get it, one day we'll go up there. I'm sure we'll bring one of them back and put it in the Smithsonian or something. But so that's where Spirit's final resting place is. And it's a shame we didn't make it down to Von Braun because there's some interesting rocks that cap that formation, and then that Goddard crater is off to the left of Von Braun. And if you look real closely, you can see like a little rocky ridge skirting up the flank of Von Braun. That's part of that crater called Goddard, after Robert Goddard. The next slide, moving on to Opportunity on the other side of the planet. Opportunity had an easy life because Bert was driving a lot easier driving than Spirit. Had a real rocky area to cross to get before we got to the hills, and we had to climb hills. Opportunity had basically a tabletop to go across. This picture here is a real picture of Mars. This is Endeavour crater. It's the first crater we went down into back in the spring of 2004 in April. And that's just a CGI image of the rover, but to scale to show you how big it would be compared to this crater we were in. And if you look real closely over there on the left-hand side of the layered rock, if you look, you see there's layers of this rock material making up the wall of the crater. It looks real bumpy, a rough-looking texture to it. That's because of all these little blueberries that are in there we discovered. And so the next slide, this was the first picture that came down the night we landed with Opportunity. And the camera's folded down on the mast of the rover before it pops up. And this picture came down in the control room, in the science room. People were like gasping, you could hear the jaws hitting the ground because this was like, what is this? This is so different than what we've ever seen with the Viking missions or Spirit, or even the Pathfinder mission. It's different. We know what we're looking at here. It's just something different. You're looking at an alien planet. Well, what that is we landed in a little crater. It's only about 60 feet in diameter. We rolled into there with the airbags. And that rock over there is about 25, 30 feet away. And that's outrock. Now, to a geologist, that's a big deal because most of these other places on Mars we've been is loose rock laying on the surface. We call it float. And the problem with that float is we don't know where it came from. The rocks in outcrop, those rocks that we're seeing there were basically born in place. They have not been moved by landslides or impacts or anything. those rocks, when they form, they're still sitting there this day. And that's what a geologist wants, because when you get to an outcrop, that is a great geologic history sitting there. And the older rocks are on the bottom, the younger rocks on the top, so you can build up a geologic story there. Now, when we first saw this, we're thinking, okay, how do we drive over that? That's probably a big, big ridge. Well, we didn't have our stereo pictures down at the time. That ridge is nothing but like a curve. It was like, no, we started really calling it the Great Wall, and it really wasn't. The next slide, that's a color picture of that area. It was only about the size of a curve, so it was easy. We climbed right over that thing. But we spent about 2 months studying that rock. And this rock is very interesting because those are ancient lake beds on Mars, okay? So Opportunity found the gold mine. We rolled right into it, okay? We were only, like I said, 25 feet away from this. We drove off the lander, and there we are. And if you look closely, you can see the rock is layered. It has some inclined bedding, which we call cross beds, and it's got these little blueberries all through there. And so these are old lake beds that existed here. And this crater was called Eagle Crater. And before we landed, we had a final team meeting, and we were getting ready to break the meeting. And I asked Steve Squires, I was like, what are we going to name things on Mars when we get there? Because we're driving. We're going to be seeing new features. And he's like, I hadn't even thought about that. And he said, all right, Rice, you're in charge. Come up with a naming scheme. So that was kind of cool because I've named all the craters on Mars we explored. And the theme with Opportunity, all the craters were Opportunity are famous ships of exploration. Well, this is Eagle Crater. That's after the Apollo 11 lunar module Eagle. And where we are right now with Opportunity's Endeavour Crater, that's James Cook's ship, is Exploration of the Pacific. All our crater names in Opportunity's landing site are named after famous ships of exploration. And Opportunity is also looking at a crater, small crater now called the Spirit of St. Louis. I think everybody knows what that one is. Now, the few craters we saw with the Spirit were named after paleo lakes on Mars because we thought we'd see lakes in the Gusev crater, which didn't really pan out. But anyway, that's the outcrop, which we spent 2 months studying because that was what we went to Mars for. And we found the lake beds. I mean, that was like, now lakes on Mars are commonplace. Everybody, it's like, of course. But believe me, when I was in grad school, my dissertation was on ancient lakes on Mars. And you go to science conferences and people just about ready to laugh you out of the building. I thought, lakes on Mars, are you crazy? Like, you're stupid. There ain't no lakes on Mars. Now, it was really neat to be part of the team that found lakes on Mars after writing papers and doing work on it when it was really highly controversial. Now it's scientific dogma. There are lakes on Mars. Next slide. This is a close-up from a microscopic imager on the end of our arm. And you can see, we put some lines in here to kind of show you the rock is layered. You can see some of these, the black thin lines, some inclined layers. Those are the cross beds. That tells you this was put down in a current of water, flowing water, little small streams. And if you look real closely, you can see these spherical little objects. Those are the size of a BB. Those are the blueberries in there. And so what happened here is you had a lake. And these lakes are kind of shallow lakes. You may have been waist deep or something. They weren't like Great Lakes deep. But they were shallow, probably ephemeral lakes that kind of came and went over time. But they were there for a period of time, geologic period of time. And then later on, we probably had the groundwater table rose up and it got wet and damp again. And these minerals got in there and formed these little concretions. Those are what the blueberries are, the round little things that came in after the lake beds and were deposited in there. And the blueberries are made of hematite. And so before we landed, we knew the hematite was there. We had no clue it was going to be like these little blueberries, but we knew it from orbit, from thermal emission spectrometer in orbit on Mars Global Surveyor at the time. So we knew the big deposit of hematite. And all the stories of hematite, how it be deposited, were involving varying amounts of water. And obviously now we know there were lakes there. That's the story with the hematite. The next slide, like I said, Opportunity landed in a very easy place to drive. It's like a tabletop. This is, you can see the upper right-hand corner, you can see the little crater we landed in, Eagle Crater, and you can see our lander there with the airbags in the center of the crater, the little bright dot. And then looking 440 meters away, we saw our back shell and parachute sitting out there on the surface of Mars. That's how flat it is, okay? Our camera poked up above the shallow little crater, looked straight out, and saw our back shell and parachute sitting out there, 440 meters away. And you can see how flat that surface is. So Spirit had a tough time driving across a bunch of busted up lava flow, and Opportunity had it very easy. I mean, Opportunity landed exactly where it needed to be to make the big discovery of lake beds. And then when we started driving, we had easy driving to do. Next slide. This was, we came across our heat shield, Opportunity again. And once again, you can see how flat the landscape is. There's hardly any rocks there. It's mostly little ripples of basaltic sand. And it's not in this picture, but down in the foreground, if it was bigger mosaic, you would see a big thing the size of a basketball chunk of metal. It's an nickel iron meteorite, the first meteorite we found on Mars. And then a couple billion years later, this heat shield falls out of the sky. So the thing about this location on Mars is you don't want to hang out here very long because chunks of metal fall out of the sky pretty frequently here. And so we went and looked at our heat shield. The engineers wanted to look at the heat shield to see how it survived the entry to the Martian atmosphere, because engineers always over-design these things. But now we have a piece of hardware that went through the atmosphere, and by looking at the damage the heat shield got from re-entry, we could determine, do we need to make it as thick as we did? Can we cut back on things? So that fed into the heat shields that flew for Curiosity, almost a decade later. And so we looked at that, and it was funny because Lockheed Martin had developed the heat shield systems. They were like, when you get up there, it's kind of like, that's our kind of trade secrets. You can't let anybody look at it. And we're like, really? Well, we're going to go look at it. What are you going to do about it? So, and of course, we knew what it's made of. And there's even some argument, why did we waste our time looking for it? Because we already know what this is. We brought it with us. But like I said, the engineers had a reason to look at it because it was going to feed forward in future designs for heat shields. The next slide. Mars gets these dust storms up there, and sometimes they can engulf the whole planet. And that's not a very good environment to be in for your solar-powered vehicle. So this slide here is pretty interesting. This is we almost lost Opportunity. This is actually way back in the summer of 2007. And we almost lost Opportunity because it almost froze to death. These pictures, if you look at the top of that picture, those numbers, tau, and you see those numbers, tau is atmospheric opacity, basically how much dust is in the atmosphere. The bigger that number gets, the more dust is in the atmosphere. You can see it as you go across the top of the picture. Now down at the bottom, you can see that, like I said, a SOL, S-O-L, that's what we call a day on Mars, because it's longer than a day on Earth, and to keep confusion from that, so we call it a SOL. Those numbers at the very bottom, like that 1205, 1220, that is day 1,205 on Mars, 1,220, and so forth. And then below that is local time. So what you can see here is these pictures are all taken looking at the same part of Mars, almost exact same time of day. And as you work to the right side of that slide, you can see how dark it got at about 11 o'clock in the morning on Sol 1235. This dust storm lasted about a month, and the vehicle was really getting severely depleted in power because we couldn't recharge our battery. We're not getting enough solar power. So we were able to dial in some calibration to basically just put enough energy in there to keep us alive. And we weren't doing any science. We were just hunkering down, trying to stay warm and trying to survive, do minimal, really hardly any science. We were measuring the atmosphere opacity, the tau. But we survived it. But that was kind of a close call Opportunity had. And the next slide.
Wow.
This is taken from, the top picture is taken from Mars Reconnaissance Orbiter. This is Victoria Crater, and you can see a nice field of sand dunes on the floor of the crater. And if you look down at the bottom of that slide, it's hard to get a whole big panorama from the Opportunity rover in here. That is Victoria Crater from the surface. An Opportunity drove there. We took about a year and a half to get there after we left Endeavour Crater. And, we just figured we'd strike off and go to the next biggest crater. So we were leapfrogging across the surface of Mars looking at craters. Now, I got to tell you, after we spent about 2 years exploring Victoria Crater and all these little alcoves and bays. And the next slide, this is taken from the Mars Reconnaissance Orbiter, the HiRISE camera. And it's the most detailed camera that's ever flown to Mars. You can see our rover tracks coming up to the rim of the crater. And if you look real closely over there, Opportunity, you can see the rover sitting there over by Duck Bay, up there between Duck Bay and Cape Verde. That's our rover. And the next slide is a little zooming in on the rover. You can see the shadow a shadow from the mast of the camera. It's an unbelievable picture. That's the rover sitting there. And it's taken from about 200 miles high. above the surface of Mars. But that's really a pretty cool picture of Opportunity kind of in action doing work there. Next slide is this kind of all the work we did up at the crater there. You can see all these loopy little trajectories went around exploring these alcoves and bays. Like I said, this took about 2 years. And then finally we wrapped up our work there, and the rocks we've discovered down there. The next slide. Here's a close-up of some of the rock. And once again, for a geologist, this is kind of like what you want. It's outcrop again. And the rocks are in place, and the older rocks are at the bottom, the younger rocks near the top. We spent these rocks here are very similar to the rocks we'd already seen previously in Eagle Crater, which are lake beds, and Endeavour Crater. So we knew this big rock, this unit of rock that was deposited, was laid over a very large area of Mars with these lakes that persisted for a fairly long period of time. And so, because the rocks are all the same, and in contemporary processes, there are sand dunes down the floor of there. But people wonder how tall things are, how big things are on Mars. It's hard to tell if you're not used to working with the data. There's nothing for scale there. You have no idea how big anything is. There's no telephone poles or houses or people to give you an idea of the scale. So, see, the next slide should illustrate that. This is a real picture we took with Opportunity of Victoria Crater, but we put a CGI rover to scale, because obviously we can't take a picture of ourselves. But that's how big the rover is compared to part of the crater. And we drove out on the promontory there, you'll see. We wanted to go further, but the engineers were getting kind of skittish, and they were like, nah, because what if we slide off or something happens? And if that does happen, that's the end of your mission. So that's about as far as they let us kind of creep out there. And this is kind of a neat picture. If you look over there in the background, you can see some big boulders that have slid down those slopes. And once again, you can see all the rocky outcrops that we explored there. And once we finished at Victoria Crater, we're thinking, okay, what are we going to do next? Because the next crater is a long way off. Next slide. This is just a close-up of the rock. I mentioned the blueberries, the hematite blueberries. Those little round spherical objects all in there. And this is more of the lake beds. And some of these, so what happened, lake beds are put down here. And then over time, sand dunes kind of came through there. A lot happened on Mars over a long period of time. So the climate kind of shifted back and forth from little small, like playa lakes, like you get in the desert southwest, to then, get more desert dunes coming in there. And it kind of alternated back and forth throughout history in this region here on Mars. The next slide is a close-up of the blueberries. And if you look over there, that all the squiggly lines, we have something called a Mossbauer spectrometer on the end of our arm. And Mossbauer spectrometer is for looking at various iron compounds in the soil and rock. And we came to an area the berries are concentrated. We call it the berry bowl. And we put the spectrometer down there, and sure enough, we got this hematite sextet, we call it, at the very bottom. You can see down there in red, popped out. And then we measured normal surface soil without the blueberries, and we could compare it, and you subtract things out. So we know for a fact that the blueberries were made of hematite. And another interesting thing we did is, I don't know if you ever took Geology 101, but one of the first things you do is learn about minerals, okay? And you have a laboratory part of the class. You will have these porcelain white streak plates. Those certain minerals leave streaks behind when you scrape them across the surface. Well, hematite, when you scratch it, leaves a reddish brown streak, okay? And as we went up to the outcrop of the rock, we have a little thing called the RAT, the rock abrasion tool, which is kind of like it's not really a drill. It kind of goes in a couple millimeters in the surface, cleans off the dust and the crud on the rock to give us a fresh surface exposure. And we cut through some of these blueberries, and sure enough, this little red iron stain was up there on the rock, just like doing a test of a streak plate in Geology 101 class. So, and then with the spectrometer, we know for a fact that the blueberries are made of hematite. The next slide is just, I kind of already alluded to this. This is kind of, a cartoon sketch of the inside of the crater, showing we have these ancient sand dunes and the groundwater forming the lakes, and then some stream deposits at the very top. And this stuff kind of alternated back and forth throughout the rock column. So these lakes would be there, they'd go away, they'd come back. So it was a large period of history. Unfortunately, we can't say exactly how long this lasted because we have no way to date these rocks. We just get them back here on Earth and put them in the laboratory and date them to get exact ages. But we can get a relative age sequence. Like I said, the older things are on the bottom, the younger stuff's on top. But we can't really bracket how long these different episodes lasted with any great deal of accuracy. The next slide. As you can see, Up there where the word endurance is, there's a crater there off to the right of the quotation mark. Excuse me, to the left of the quotation mark. That's endurance crater, a little bitty, barely pinprick in this image. Then you can see we headed down to Victoria Crater, which was the crater I was just talking to you about. We spent 2 years. After we finished up our work at Victoria, which took about 2 years, we were thinking, okay, what are we going to do now? Where are we going? All right. And we figured, let's go to Endeavour Crater. It's a big crater. It's 20 kilometers across. Let's go for that. But that was 12 kilometers away. And it took us 3 years to get there. We thought, let's try it. But it took 3 years of driving to go that 12 kilometers. We made it. And that's where we are today. You can see on the western rim of Endeavour Crater is where our opportunity is today. And the next slide. Once we got to Endeavour Crater, we found something we thought familiar. We thought these were more the blueberries in the rim of the crater, some outcrop we found. But we were wrong, because once we went up and analyzed it with spectrometers, these aren't made of hematite. To this day, we don't know what these things are. We don't know how they formed. We were fooled because I was up late one night. The pictures come down at different times of day. I was up late, and Steve Squires, we were trading emails, and we were like, yeah, it looks like more blueberries. And then once we drove to the outcrop and measured it, we were wrong because, yeah, it looked like them, but doesn't mean it is. And it turned out these aren't blueberries. These aren't made of hematite. We have never seen this anywhere else in this one location. We came across this back in 2011. We thought we'd see it again. We haven't seen any more. We don't know what these things are. There's a couple ideas out there, but we never really were able to nail this thing down. So it's kind of something kind of gnawing in the back of our mind. And unfortunately, we haven't seen any more occurrences of it. But this is different from the blueberries. If you look at some of the big ones in there, the biggest ones are about 4 or 5 millimeters across, a little bit bigger than a baby. But they kind of have like this hard outer exterior shell, and the insides of them kind of are more a little easily erodible. So like they kind of rotted it out and let these like little halos and things around. Don't know what they are. I mean, still kind of unresolved question. So anyway, that was a place called Kirkwood Outcrop. The next slide it's just kind of outdated, the distances here, but it's interesting because now the world record for off-world driving was held by this Russian Lunokhod 2 rover, unmanned robotic rover the Russians sent to the moon in the early 1970s. It drove around 38 kilometers, and the record next to that was the Apollo 17 lunar rover that the crew drove about 37.2 kilometers, actually 35.7, I've looked at a graph there. Well, now Opportunity's passed all this stuff. Opportunity is over 40 kilometers now. So we have the world record in off-road driving for a rover vehicle, and we're still driving it. So it's going to only increase. But it was kind of fun because I was glad we beat that Russian record. Because what the Russians did, after Apollo 17 left the moon in December of 1972, they landed Lunokhod 2, and they purposely wanted to beat our record, our distance. So that was a little kind of propaganda thing for them, because they never were able to land astronauts or cosmonauts there who beat them to the moon, part of the space race. But they beat our distance with the rover, and okay, but still our rover had people driving it, and we did that distance in 3 days. It took them about 4 months to do their distance. But anyway, so it was really neat to kind of beat the Russian record, and the Russians congratulated us when we beat it. And I knew a Russian scientist, we had emails back and forth, who worked on that Lunokhod 2 mission. And he said, Jim, when you get close to the record, don't drive the rover anymore. Don't beat it, because we've had it for almost all these decades. And it was kind of a friendly competition back and forth. When we beat the record, they sent us congratulatory notes and stuff, and it was all kind of fun. And when we did beat it, there was a crater just so happened to be nearby the point we beat it. We beat the record, and we named that crater Lunokhod 2. So it was kind of a neat little story how that worked out. So Opportunity now actually is kind of the distance of a marathon, 26.2 miles, or a little above 40 kilometers. All right, the next slide. This is where we first got to on Endeavour Crater Rim with Opportunity. And we called this place Spirit Point in honor of Spirit, the rover that had died a couple years earlier. And if you look back there where it says location B in red, it says iron magnesium smectite location. That's where we found those weird, we call them newberries. They weren't blueberries, we call them newberries. That's where we saw it, found those there on part of the rim. And we explored this area for a while, and this was called Cape York. We long left this. We drove across the plains. Next slide. But before we left, though, this is one of the biggest discoveries that Opportunity made besides the lake beds. Like I said, looking at the picture here, you think, okay, it's just a bunch of rock again, big deal. Well, for us geologists, there's a lot of stuff going on here. It's a very big deal. This lighter tone rock is made of clay. Okay, the fancy word is phyllosilicates. And clays are a big deal on Mars because even on Earth, the way clays form, you have to have a lot of water around for a long period of time geologically, because what you do, you basically soak these rocks or bathe these rocks underwater, and they alter, they change their mineralogy, and you form clay minerals. That's how we get clay minerals here on Earth. Rocks are drenched in water, and over time they break down and erode into clay minerals. Well, you have to have a certain kind of water to do that. It has kind of a neutral pH. Those lake beds I showed you we found earlier, that water there was like battery acid, very acidic, okay? Now, there are certain life forms on Earth that love that kind of stuff, okay? They can thrive in that. But when we came to this area here with the clay rocks, this tells us the water is here for a long period of time again on the surface, and the water was like drinking water. If you'd have been there a couple billion years ago, you could have scooped that up and drink it out. It's neutral pH, just like water you drink out of your tap. So this neutral pH water is there for a long time. A lot more life forms on Earth can thrive in this type stuff. So this is an environment, once again, another environment, like the lake beds, like the hot springs, where life could have thrived on Mars. We still don't know if it happened there or not, but we did identify for the first time places on the planet where it could have got a foothold. So these were the clay minerals that we found. The next slide, as I said, we drove across the plains to this big part of the crater rim, and see where it says Cape Tribulation up there. That's where we are up on that crest up there now. And Botany Bay was the flat plains area, we called it, because this is Endeavour crater, James Cook ship. He'd explored a lot of Australia, among other places in the Pacific, Hawaii. But so Botany Bay, a lot of these names are after some areas down in Australia. And Cape Tribulation is also in Australia, in Solander Point. So we're up on the rim of this crater now, crest. Next slide. This is our backward looking, our aft hazard avoidance cameras looking as we climb up a hill of the rim. And it's hard to tell if you weren't familiar with it, but you can see our tracks coming up the hill. You're looking down into the floor of the crater off to the east there. And you can see we're sinking in a little, but not too much. That's kind of normal sinkage right there, not anything to be concerned about. And there's some sand dunes, little ripples off to the left over there. And the next slide, this is a discovery we made last January a year ago. A little bitty rock, only about, about 2 inches across, 2.5 inches. We named it Pinnacle Island. Now, it's an interesting story here. We had a team meeting. We have a team meeting once a year. We all get together. We're scattered all across the United States. And we have a couple team members in Germany and Denmark. But so we have these team meetings where we all get in one room together for a week and discuss what we've been doing and what our future plans are and our detailed science discussions. And we take a lot of pictures of these rovers. Those are our eyeballs. We need it to drive. We need to do the science analysis. During the team meeting in January, we were having a team meeting back in Washington, D.C., because that's when the Smithsonian Air and Space Museum opened up an exhibit, because it's our 10th anniversary of Spirit landing on Mars and Opportunity landing on Mars. So they had a special exhibit up there. So we wanted to go. We were invited to the grand opening. So we had our team meeting back in D.C., because we usually have it in Pasadena. So we're back there in this conference room, and one of the guys on the team says, that rock wasn't there a couple days ago. We're like, what? We thought he was telling a joke. And sure enough, that little rock you see down there in the big picture, in the little black box and zoomed in the center of the picture, that rock appeared, okay? And things like that don't usually happen. So we started thinking, okay, was it a meteorite? Did another meteorite fall down, discover another meteorite here? So we didn't know what we had. It's a very small rock. And we're thinking, we're on a slow, low incline, but not a real steep hill where we are right here at this point. I'm like, where did this rock come from? Because we had a before and after picture, and that rock wasn't there, which is very strange. And we're like, and at the time, we were getting ready to write our extended mission proposal. Every 2 years, we have to write this thing to keep our funding levels going. We have to justify we're doing good science, making big discoveries. And it came at an opportune time, because this is one of the most unusual rocks we have found on the surface of Mars with any rover, okay? A small rock, and the rock just so happened was buried in the surface partially. We know what happened now. It wasn't a meteorite. We call it a turn in place, like a tank turn, where we kind of rotate the vehicle. And this rock was just barely poking above the surface. And when our wheel came along, it popped it out, it rolled, and it rolled, so it was upside down. So the bottom is facing up, it was down to the subsurface. It's the first time this is part of that rocket seen the sunlight in who knows how long. But the other weird thing about that, it landed right in our workspace for our arm, perfectly placed. Now, our arm has arthritis now, okay? We've lost our motion. Once upon a time, it could go this way, that way, it could do everything. We've lost our flexibility because some brush motors have worn out the arm. So now we have a limited, like we call, work volume where that arm can work. If you're not in that work volume, you've got to tweak the rover around, and sometimes it can take days to get to what you want to get. This rock lands exactly right when we extend our arm. It's right there where it should be. And a lot of unusual circumstances. This rock was very rich in magnesium, manganese, which is a water storage. This rock was soaking in a lot of water. We thought we'd see more occurrences of this, but that's only, once again, a one-time shot where we found this thing. It's just total serendipity the way we found it. And it played a big part in our extended mission proposal. So that was, as a detective story, we had to figure out how this thing happened. We finally figured it out, but it's still an unusual rock. Seen nothing else like it. So that's Pinnacle Island. The next slide. This is alluded to the distance. We've done a marathon distance with Opportunity now, 26.2 miles. It took about 11 years to do it, but like I said, it wasn't really a race because we were doing science along the way. And so that's kind of our record. And it shows you a little graphic, some of those craters. We started out in Eagle Crater all the way to Endeavor. And that's kind of our distance right now. Because since we got to our present location, we haven't driven very much. We're doing a lot of work in this called Marathon Valley. Next slide. This is where we are. So orbital view from the HiRISE camera, the Mars Reconnaissance Orbiter again. And if you look in there, this is the rim of Endeavor Crater. It's kind of zoomed in, so you can't get a proper perspective of it. But if you see that kind of thing, this darker shaped, teardrop, almond-shaped little feature in there, with a dark floor among that kind of lighter toned rock, that's the Spirit of St. Louis crater, okay? And it's got this little mound on the floor of the crater. That's what we call the Lindbergh Mound. And we're currently, as we speak to you, I speak to you right now, Opportunity is parked in the north rim of the Spirit of St. Louis crater. We just came out of conjunction a couple days ago, so we're starting. When Mars passes behind the sun, it happens every 26 months. It's a period of about 3 weeks or so. We do not communicate with the rover. The sun's in the way. The rover doesn't drive. We did build up about 3 weeks worth of commands for the rover to do minimal science, measuring the atmosphere, dust, taking some pictures, and measuring some rocks. But no driving is allowed because we're out of the loop. And so it's parked. So it's sitting there on the north rim, and the little valley feature in is called Marathon Valley, obviously because we've driven a marathon distance. This area, the Marathon Valley Spirit of St. Louis crater area, is very interesting because we still don't really know what's going on there. Spirit of St. Louis crater is a very unusual crater. And the next slide, this is kind of hard to get this big picture on the screen, but that is looking at the Spirit of St. Louis crater, that oblique kind of looking teardrop-shaped crater. You can see the Lindbergh Mound sitting there on the floor. And then that other hill off there towards the left, that's called Swan Hill. We're parked over there between Swan Hill and the Lindbergh Mound now. And we're trying to figure out what's going on here. And I don't really have a story to tell you because we haven't figured it out yet. We will, but science can take time. You got to collect a lot of data and analyze it. And we're in the early stages. We got here a couple months ago, and we're still trying to figure it out. And this is the fun. It's the beauty of a rover, because when you drive to a new location, you got a brand new landing site. You got brand new geology. And the reason we went here is because from orbit, we detected more clay minerals, okay, phyllosilicates. We haven't found any clay so far, but we really haven't entered the valley. We're going to start in the valley the next couple days, next week or so. And hopefully we're going to find the clays there. But so far, what we found is kind of surprised us. It looks very similar to the rocks we've seen before. But this crater thing we're in, it's a very shallow crater. It's not, it's only a couple, I think it's like about half meter deep, not very deep for a crater. It's got a weird shape to it. So is that an oblique impact? Is that part of the impactor, the Lindbergh Mound? We've measured those rocks in there. We can't say exactly what they are yet. We've got to do some more work here. And the way you do geology is you cover the area, you do reconnaissance, the stage we're in now, then you go back and study things in more detail. So we're still piecing this thing together, but I think we'll figure it out. We've got a good team. And for But this is the fun part when we're scratching our heads, is what we like. It's what we're there for, to figure it out. There's no books to go reference. No one's ever done this before. So that's kind of where we are up to date with Opportunity. Next slide is a close-up of the Lindbergh Mound, looking at it from another perspective. And there's this dark red zone down there in this little box on the bottom of the slide. I noticed this when we first got in there, this red zone, like a halo around the the Spirit of St. Louis crater. And that is the rock that Opportunity is examining right now, that reddish rock. And I will tell you this, we just got some data down, I guess day before yesterday. Those rocks are kind of enriched in silica. So there's a silica story here. So was this an area where we had hot springs going off, or alteration from an impact crater, or is it volcanic heating? We don't know. We're still trying to figure this out. But that red zone of rock there on the margin around the crater is proving to be pretty interesting, because it is different than the rest of the rock. There's, like I said, a silica story there. It's elevated in silica. And we're going to do some more measurements of part of this red little margin or zone. So that's kind of what we're doing up to speed where where Opportunity is right now. The next slide is, this was taken, you can see our arm is down there analyzing those rocks, those reddish margin rocks. You can see our two wheels that are in the foreground, and the instrument deployment device, or the arm sitting out there with the spectrometer looking at the rock. So that's taken from a hazard avoidance camera. It's kind of like a fisheye lens type thing. So that's kind of most recent picture down from Opportunity. Next picture. This is my next to last slide, and this is Earth. First picture of the Earth taken from the surface of Mars. Spirit did this way back in 2004. That bright dot in the center is a planet Earth. Wow. So if you're living in the year 2004, you're in that picture. It's very pixelated because it was taken at nighttime, obviously, all right? Well, the cameras weren't designed to work at night, so it's kind of a grainy-looking picture. But that's the Earth there. That other kind of bright object in the upper right is a star, and I don't recall it. It's not a common name star. It has a designation. I don't know which one that is. But anyway, that's Earth, and that's us, and hopefully not too far down the road, some astronauts will be there and take a nice picture, some video, and show it. But that's what Earth looks like, and everything we've ever studied in our history books happened on that little dot right there. Last slide I have is, this was taken by Spirit when we were climbing Husband Hill. That's a sunset on Mars. And if I didn't tell you that, you would not know that was Mars. You'd think that's probably taken out in Arizona or something. But that's a sunset on Mars. And the thing about Mars, these pictures I've been showing you, I think you can tell it looks kind of familiar landscape. It doesn't look like something out of a weird science fiction movie. It looks kind of familiar. If you've ever been to the desert Southwest, it looks very familiar to you. Thing about it is, there's no cactus or mesquite trees or tumbleweeds, nothing out there. But the landscape is very similar. Like I alluded to earlier when I started talking, Earth and Mars, or how you want to word it, Mars is the most Earth-like planet, or you can say Earth is the most Mars-like planet. Very similar in terms of the geologic processes that operate on the surface. Like we have volcanoes on Earth and Mars. We have big floods. We have lakes. We think there are glaciers on Mars. There may be even an ocean on Mars. It's a little more speculative still, but we do know there are lakes on Mars, and this water eventually gets you thinking automatically about life, and we just don't have an answer for that right now. We do know a lot more than we did, say, before Spirit and Opportunity landed. We know there are habitats where on Mars where life could have thrived, had a good old time, but I personally think it's going to take astronauts to get there before we answer the question about life on Mars. It's a hard question to answer. And people ask me, I'm a field geologist. I spent 6 months in Antarctica at a Russian base. I've gone to the Canadian Arctic, gone to Iceland a lot, Australia, Alaska, Hawaii, obviously Arizona and Utah and New Mexico and Colorado. I would never send a robot to do what I could do, okay? Humans are the best explorers, the best geologists are humans. Well, we can't send humans to Mars right now, so we send our robotic emissaries. And these rovers do a great job, don't get me wrong, but I'm telling you, a couple of astronauts there in about a couple of weeks could have done everything Opportunity's done in 11 and a half years, could have done it in a couple of weeks, 3 weeks. Could have done it and done a better job. So you need astronauts there for a lot of reasons, but scientifically, I know it's more expensive to send people, danger, all this, blah, 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 but the best explorer, and that debate goes on, man versus machine thing. Well, in reality, the NASA program, robotic and manned spaceflight has always kind of worked in synergy with one another. Because before we landed Apollo astronauts on the moon, we sent robotic missions like Surveyor, Lunar Orbiter, Rain, to scout out what's there, and then the people follow. And that's what we're doing right now in that stage of Mars. The robotic missions are going there, learning what it's all about, finding key areas to come up and do more detailed research. And people will follow, I have no doubt. I just don't know when it's going to happen. And that's kind of too bad. I thought when I was in grad school I would see it happening by now, and it hasn't happened yet. And like I alluded to earlier, that 2035 time frame thrown out there, that's pie in the sky. There's no real dedicated program to do that. And I was talking to someone earlier today. They asked me about that. I said, I don't want to bust your bubble, but I've got to be honest with you. There's a lot of talk about sending people to Mars. That is not a real program right now, okay? And the reason it's not, if you're familiar with Apollo, the astronauts landed on the moon, what was called the lunar module, the four-legged vehicle, had the gold foil and black foil and stuff, okay? There is no work today at NASA happening on developing a vehicle to land astronauts on the surface of Mars, okay? So there's no work on NASA being done today. What kind of spacesuit these guys are going to wear on Mars, okay? The Apollo suits won't work, all right? None of that work is being done, so we're not going to Mars right now, I hate to tell you. And I think we will go. You got to be optimistic in this business because things can change on a dime. But right now, in June 2015, there is no real NASA plan to land American astronauts on Mars. It's all a bunch of talk, all right? And it's getting a lot of media attention, but the program is not there, okay? Yes, we're working on this big rocket called the SLS. It's not going to fly with people on until 2022, 2021, maybe, all right? And then that flight is not going to Mars. It's going to maybe go out by the moon. That vehicle is only going to fly once every couple of years, that large rocket, all right? And yes, last December, the Delta IV launched the Orion spacecraft. And it was all in the news. This is the spacecraft that's going to take us to Mars. Nonsense. That spacecraft is not going to take us to Mars, that Orion spacecraft, all right? It looks like a big version of Apollo, all right? That may be used in the architecture, but that vehicle is not going to take people to Mars. It's too small, too cramped. You can't have enough supplies on there to keep people alive. You got to have a different vehicle. So I don't want to be negative, but I just want to be honest and maybe get you fired up to write your congressmen and the president and senators to get a real program going, because there is no real program to land Americans on Mars right now, despite what's out there in the media. There's a lot of talk. That's kind of a good thing. It's getting a groundswell, but the hardware is not being developed and tested. There's no real plan. It's just a bunch of arm waving and talk right now. So I don't want to leave it on that note, but I do want to leave time for questions. So I'll be glad to take some questions if you got them out there.
Okay, questions? Yes?
So you were talking about the canyon, and I assume it was created from water, but is there any chance that we could somehow land a rover near or on the canyon?
The canyon Valles Marineris, we think most of it's formed by tectonic processes like the stretching of the crust, because those big volcanoes I talked about, there's a place on Mars called the Tharsis Bulge. It's like a big blister on the planet. These big volcanoes are sticking there. And that caused a lot of stresses and strain on the crust, and it caused the crust to kind of crack apart and fracture, forming that canyon early on. The canyons get also bigger because of landslides coming off the walls of it, just very similar to Grand Canyon, Arizona. And the Grand Canyon, Arizona was kind of cut down deeper by the Colorado River. But we think water may have played some role later in its history, but the way it got started was tectonic forces and then landslides. There may even have been large lakes in the floors of those canyons. We see some layered rock down there. It looks very interesting. So those canyons are be an ideal place to go because you're 4 or 5 kilometers into the subsurface, so to speak. Those are real ancient rocks down there. And ancient Mars is where it's more similar to the Earth, the ancient Mars. Current day Mars is very different. And in terms of landing there, it always comes up for landing site meetings, but it usually gets shot down because of safety. Because as you get close to those canyons, you get these big things called mesoscale, these slope winds coming off there. And that's not a good thing to happen when you're strung out in your parachute and have no control where you're going. So the safety concern is that if you get in near those canyon walls, the winds may slam you in the wall and crash you, and your mission's over. But our precision landing on Mars is getting better every time we do it. Astronauts could do it, a piece of cake. Because once you have a person in the loop, it's easy to do. If you know the story of the Apollo 11 landing, where Armstrong had to take over from the autopilot, the lunar module, to fly it, because the autopilot was taking the Eagle lunar module into a crater full of large boulders the size of Volkswagens. They would have crashed and died in there. So Armstrong had to take over and fly it manually. If you have astronauts trying to do this landing, that the canyon can easily be done. But with robotic missions, we're hands off. You know, these things come in and they're on their own sequence. So there's people are skittish about getting near those winds. Main reason. Those sites are scientifically interesting. They always come up at landing site meetings. They always end up eventually going away because of safety concerns. And the number one concern is get on the ground safely, and then you can do your work. But if you don't get down safely, you got nothing. So, and we're looking right now. We're in the process of looking for a landing site for the Mars 2020 rover. It's basically going to look a lot like Curiosity, same Sky Crane landing system, but it's going to won't have the same science instruments. It's going to be stripped down. It's going to be designed to go to Mars, and we're trying to, just starting looking for landing sites, and collect rock pores into the rock and soil and surface and atmospheric samples and leave these on the surface. Then another rover is going to come sometime later down the road, just not even on the books for being funded, pick up these samples and bring them back to Earth. That's part of Mars sample return mission. The 2020 rover, it looks like it's going to happen, although the 100% funding isn't there yet, but we think that's probably going to happen. It will land on Mars in 2021. But the next follow-up rover to pick up those samples and bring them back, I can't tell you when that's going to happen. It'd be the late 2020s, probably maybe early 2030s, before we get those things back here. But I can tell you that the landing site's being looked at for Mars 2020 right now, and by nature of the program, the next rover has to go where the 2020 rover goes to pick up the samples. The Canyon system sites did not rate very high because of safety concerns. The science, there's good science there, but safety. And, and since you're building this is like a series of missions building upon one another, you got to make sure it gets down there. So I don't think the Canyon sites are going to happen for the next series of rovers. And we may not get in there till we get astronauts going there. But I think that will be a prime site for astronauts when we eventually go.
Okay. Other questions? Yes, in the back.
You keep on talking about all this water that was there.
Can you hear okay?
Yeah.
Okay, please go ahead.
But what happened to the water? Like, why is there no more water on the surface?
Well, that's a good question. And, you hear about climate change on the Earth, and if you've studied anything, the geology, history of the Earth has always gone through climate changes. That's par for the course here, okay? Ice ages come and go, mountains come and go, oceans come and go, climates change on Earth. Well, Mars has had something similar happen because you're exactly right. We had all this water on Mars early in its history. And if you went to Mars today and opened a bottle of water, it's going to boil away before your eyes. Now, you're probably thinking, wait a minute. This guy's been telling me all day long how cold it is up there. Well, it's going to boil away, nothing to do with temperature. It's going to boil away because the atmospheric pressure is so low, all right? So the water is going to go from a liquid state to a vapor, and then it'll probably snow out at your feet because it's so cold. But bottom line is liquid water is not stable on the surface of Mars today, okay? But we know it did in the past. We found lake beds, we found dried river beds, we see all this evidence everywhere. So early Martian history, the climate was different, the atmosphere had to be thicker, relatively a little bit warmer, but I think Mars has always been a cold place. I mean, it's further from the sun than the Earth. Mars on a good day is probably like Antarctica, I think. So we had this big climate change. Global climate change, and we don't know exactly when it happened or what caused it. There are a lot of theories out there. Part of the atmosphere may have got blown off from these big impacts. There's a big crater on Mars called the Hellas Basin, and that crater is 2,000 miles wide, okay? There are other big ones up there. That's the biggest. Those big impacts surely blew off part of the atmosphere. That's a very energetic event. But we think most of the atmosphere has been lost from the solar wind, from the sun stripping it away. Early in its history, Mars had a magnetic field about as strong as a magnetic field on the Earth. But Mars has no plate tectonics. And the planetary engine seized up and quit working at some point. And when that happened, the magnetic field shut down. When the magnetic field shut down, well, now your atmosphere is exposed to the solar wind, because the Van Allen radiation belts around Earth keep us protected from this stuff. So the solar wind comes along and starts stripping off the lighter elements. Hydrogen, water breaks down hydrogen and oxygen. The hydrogen starts getting stripped away. And your atmosphere starts thinning out over time. And there's a mission we just got there called MAVEN, M-A-V-E-N, an orbiter, got Mars about not quite a year ago. And it's studying the Martian atmosphere. And it has detected already that even today, the little bit of Martian atmosphere that is there, we're seeing it stripped away by the solar wind. So that probably, those two things in combination probably took away the Martian atmosphere and caused the climate to change. And with the Curiosity mission, it landed in Gale Crater, and there's a big mound of rock in there about 3 miles high. The rover still hasn't got there. It's been on Mars almost 3 years now. It hasn't got to that foothills. It's not in the foothills down there, but it hasn't started climbing the hill of Mount Sharp. The thinking is that as it climbs up this layer of layered rock, we're going to see climate changes in the rock depicted there. That's the theory. That's why we went there. We won't know till we do it. But we're thinking maybe we're going to find rocks near the bottom where there's a little more water activity, probably acidic water. Then we go up, there's still water activity. The water's more like fresh water, neutral pH. And then as you start going up further, you're going to see that goes away too. And now you're left with the desert world we have on Mars. That's what we hope to see as we climb up that mountain in the layered rock. But and maybe see a break where that climate change occurred. But we just don't know right now. But that's kind of our theories out there about the Martian climate.
Very good. Is there a question here? Yes.
On the blueberries, you said they were mostly hematite. Wouldn't they? Why are they blue? Wouldn't they be more red, being as they're iron oxide?
Yeah. It's kind of misleading because we have these different filters on our camera. We call them geology filters, and sometimes you'll see our pictures. They have these garish colors like oranges or purples or blues. Those are false color images, and the reason what we do. They're different filters. They bring out subtle details in the rock, in the mineralogy. And it tells us on the team things to look at that the naked eye won't see. The blueberries, if you were on Mars, looked at them, they wouldn't be blue. You're right. It'd be kind of a grayish red color. And but some of the pictures that were released out there, they stand out really as blue. And we just call them blueberries because they're about the size of a blueberry kind of. And in our false color, they look blue. And when we first saw these things, we didn't know what they were. Because when you find spherical objects, geologically, that's very unusual. And we saw these things and like, what in the world is this? And at the time, we didn't know what they're made of. And, we were figuring out what to call these things. And, you don't want to call them spherical particles. That's too much mouthful of words. What is it? So we had all these terms thrown out there. And, I was just sticking around. So blueberries, this got kind of stuck. And then Steve Squires, they're like blueberries in a muffin. They're studded on the rock. So it just kind of stuck. But they're not really blue. So you're right. There'd be more like a dark kind of reddish gray kind of color if you were there. But you'd see them because of their shapes, but their color wouldn't really jump out at you that much.
Okay, thank you. A couple more? Yes.
You mentioned how NASA has no plans for human exploration of Mars. What do you think of private companies like SpaceX, who mentioned some of the plans to send humans to Mars?
Yes, SpaceX, of all the commercial companies, I hate to use the word commercial or private because they're all being subsidized by the U.S. government. They're not really completely private, but of the companies out there, SpaceX is the one that's got their act together more than all the others. And they've flown some unmanned cargo flights, resupply flights to the space station several times. They're getting ready to launch again tomorrow, I believe, and try to land on the barge out in the ocean, the first stage back down, the reusable first stage. But they're not ready to put people in space yet. I think they're still, 3 to 5 years away from that. They'll eventually do that, but these are just going to Earth orbit, okay? They're not going to the moon or Mars. I have a hard time seeing a private company or a private enterprise going to Mars when a whole nation can't do it. It takes the money. It's expensive stuff. It's probably going to be some type of international consortium of countries that do it, like the International Space Station. I don't know, Elon Musk, the guy running a SpaceX, says he's going to have people on Mars. He's going to go and wants to be buried there. I hope he's right. I'd love to see it happen. But, it's a lot of talk. I've heard about this stuff for decades. It hasn't happened yet. But SpaceX eventually will get people up into Earth orbit. It's a start, okay? Of all the groups out there, they're the ones that got their act together. This Mars One stuff you hear about, people, the one-way trip to Mars, I have a hard time thinking they're going to do it. The time schedule they have out there, once again, it's all about money. They say they can do it for, I think, around $6 or $7 billion. That's pretty cheap. Curiosity mission costs $2.5 billion. Okay, a robotic mission, and Mars is just a hard place to go. We can do it. We could have done it in the 1980s after we landed on the moon. NASA came up with a blueprint of what the future plans are, presented it to the White House, the Nixon White House at the time. And they had two different scenarios. One was to go onto Mars, which is the next logical step after exploring the moon, using the Apollo hardware upgraded, the Saturn V launch vehicle. And the other one was kind of the space shuttle. It was a space shuttle today, space transportation system. Well, the Nixon White House was like, the Mars mission is a lot more expensive. We don't want to do that. Let's go for the cheaper option, which was space shuttle. The space shuttle, the original design for that isn't what we ended up with. Kind of NASA went in asking for a Cadillac and got a Volkswagen kind of because it wasn't funded properly. But so we could, and the plans were to land on Mars around 1984. And I think that probably would have happened if we'd gone that route, but it didn't happen that way. We know how to go to Mars. The engineering, the sciences is cut and dry. We know how to do this. The thing that's going to take some work is the human factors, what the human body has to endure to go there and back. But there are no showstoppers. I mean, a lot of work needs to be done, but if we had a committed program properly funded with leadership, I have no doubt we could pull it off. And it'd probably take 10 to 15 years to do it if it's properly funded. And you need shorter time scales. When you talk about decades-long projects, that's not going to happen, okay? It's just not realistic in this country. And you need kind of a timeline that is manageable, and something's going to happen. You can see the returns happening. The problem with Mars, if you want to call it a problem, is the human factors, because as the crew travels there with chemical rockets, which is all we have right now that are working, if we get nuclear rockets, it's a game changer. We can get there quicker, but the transit time is going to take that trip there and back is 2.5, 3 years. And people, when they get away from the Earth, can be exposed to radiation in deep space, the weightless environment. But I think we could do it. If we wanted to go that route, we could pull it off. But we need a lot more work with human factors. And the other thing is, once you commit to going to Mars and you lift off, within about 3 or 4 weeks, you're going to Mars. You can't turn around and come home, okay? Orbital mechanics takes over, and you can't wish that away. And you don't have enough fuel to turn around and track the Earth. The Earth's moving around the sun. So once you commit to Mars, very early on in that mission, you're going to Mars if you like it or not. So, it's a different ball game than going to the moon. The moon is only 3 days away. And personally, I think we need to go back to the moon first, because the people that did that, let's face it, those people are retired or dead now. The last time we did that was in December 1972. I have no doubt we could do it again, but we need to learn to do that again. We have no experience on another planetary surface since Apollo 17, all right, over 40 years ago. So the moon is convenient, 3 days away. The moon is the test bed. And I tell people, if you go buy a new piece of camping gear, like a tent or whatever it is, all right, you're not going to try it out near Mount Everest. You better take it out in your backyard and learn how to set it up. Okay, the moon is our backyard. And it makes a lot of sense to go to the moon. There's a lot of scientific reasons, but just sheer operations and logistics, I would say you need to test things out on the moon before going on to Mars. Even though I love Mars, but I think we'd be insane to strike out for Mars right now. I don't think we could. It's not a good program. The thing about the moon, if you get there, you have to have an exit strategy, because you don't want to get bogged down on the moon. And so there's a lot of things that have to be ironed out. But the moon is a convenient place to test out life support systems, a lot of stuff. And granted, the environment of the moon, granted the environment of Mars, they're different, okay? A day on the moon is 14 Earth days. A day on Earth is like a day on Earth. A day on Mars is like a day on the Earth. Mars has seasons, different things. Mars has an atmosphere, the moon doesn't. So there are some significant differences, but I think you could test out a lot of things. And if you could do it on the moon, which is in a way harsher environment, you could alter it for Mars. But so I don't know. The one-way trip thing, the Mars one thing, I don't think that's going to happen. I'd love to be proved wrong and eat my words again. I just don't see that one-way trip thing. And these people who claim they had to go on a one-way trip, that's easy to talk about right now. When you roll out to the launch pad, you get around that rocket, you're never coming back. Well, those people are going to bail out. I'm sorry. I don't buy it.
Okay.
Plus, don't you want to come home and go there and come back? I mean, come on,
That'd be a great idea. There was a question.
The reasoning behind it is a one-way trip is half the price to do it. You don't have to bring it back, okay? And eventually, I do think we will settle the planet or colonize it, whatever word you want to use. I think that's going to happen somewhere down the road, because human beings, that's what we do. Look at our history on this planet. We started out in Africa. Now we're all across the globe. We're actually, 3 of us right now, circling the globe, okay, in a space station. So we will go to Mars. I I don't know when, I don't know who, but countries that are with take the risk will reap the rewards. That's history proves that out.
Okay, just one last question, a little housekeeping. After the question and the answer, if everybody would just stay seated, I'd just like to say a few words afterwards, and we'll thank Dr. Rice, but I don't want everybody to bail out. So your question, please, sir? Yes, right here. Did you have a question, sir?
Yes,
Yes, please.
yes. When is the Mars rover going to explore the atmosphere?
Well, most of these rovers are geology missions to learn about the rocks, the history locked up in the rocks, the water history, and looking for any signs of possible life. So the atmosphere itself, we're doing that with the orbiter right now. The MAVEN mission is primarily just to study the Martian atmosphere. We have orbiters also, like the Mars Reconnaissance Orbiter, the Mars Odyssey Orbiter, which is mostly studying the surface, remote sensing instruments looking down the surface. But we do study some of the atmosphere with the dust storms and things like that. So in terms of a dedicated mission on the surface to study the atmosphere, that's probably not going to happen, because once you get to the surface, you're there to study the surface. Now, the Curiosity rover does have a meteorological package on there to measure the humidity, the wind speeds, temperatures of the surface at the surface of Mars, the landing site. We don't. Spirit and Opportunity, we're a purely geology mission. We don't have any meteorological instruments on there. Curiosity, like I said, can do local meteorology at the landing site. The Mars 2020 rover probably won't have any of that, I'm thinking, because you want to just basically scout around the surface, collect your rocks. And the follow-on rover to pick up those samples probably won't do it. They may leave behind meteorological packages, possibly, to monitor weather long-term. But yeah, it's mostly about the surface right now, and the atmosphere has been studied. It's been studied because it's important, because the atmosphere drives these dust storms, and the atmosphere is not the atmosphere we had, 2-3 billion years ago. So it'd be interesting, because we want to get samples of the atmosphere with the sample return mission to bring it back on Earth to analyze. It would be a really great thing if you get to the polar areas to do ice core, like we study our climate on Earth through ice cores in Greenland and Antarctica. Okay, get the polar caps on Mars, get an ice core out, because the atmosphere is trapped in these bubbles of air in there, and you can monitor. It would be interesting to see what we find. I mean, you can speculate. That's all I can do right now, because we haven't been to the poles of Mars. But imagine taking an ice core on Mars, getting it back, analyzing it, reading the climate history. Imagine if the ice ages matched it with the ice ages on Earth. That would be interesting, because you would know, number one, the climate is an external cycle. The sun's driving it, okay, which is, I'm sure, part of that story. Because look, you got a big sun out there, a big star, that's got to be that's driving your weather and your climate. And the big debate now is how much are we influencing the climate on the Earth and stuff. And surely the sun plays a role. I mean, the years of quiet suns and noisy sunspots, all these things, that plays a role in it. I mean, there's no way you can deny it. The sun is the energy of the solar system, the engine. And like I said, it's pure speculation to see if these things would match up on Earth and Mars. If you get the big ice cores out of Mars, that'd be one of the first things I think people would look at. So I think we'd do it no matter what, because the climatic history of Mars is locked up in their ice cores like it is here on Earth. So that would be it'd be really cool if it got in sync. Probably likely, but don't know till you do it.
Okay. Dr. Rice, I'd like to thank you very much. This is extremely informative. We appreciate your time. I know we went way over, but I think everybody had a lot of questions. Okay. It was great. Everybody, if you would, please, with a round of applause for Dr. Rice. Thank you very much. I'm off camera, Dr. Rice. You can't see me, but I'm going to go ahead and hang up. I'll follow up with an email tomorrow. But again, thank you very much for your time. This was a wonderful event tonight. And hopefully sometime in the future, maybe we can Skype again.
Well, thank y'all. I appreciate y'all coming out tonight. It's probably kind of late because it's 10:05 your time. But, I was going to be doing this in February originally, but you had a little winter time up there. And so everything kind of worked out. And once again, thank y'all for your interest in coming out. It's been a pleasure talking to you tonight.
All right. Thank you again. Good night.